Our final keynote speaker is Eugene Olejnik. He's head of the customer team at Kipu Quantum, and he's going to talk about quantum software pathways for industry applications. So, last but not least, how about a hand for Eugene?
Sure. Hopefully this microphone is working. You can hear me. All good, thanks. Just waiting for the... How much time do I have? 20 minutes? Should be 20. Yeah. All right. Hi, everybody. My name is Eugene. I'm from Kipu Quantum, and I'm leading the customer organization at Kipu Quantum. So essentially, my team is working with customers on the quantum use cases every day. Just a bit about who we are and what we do. We are a German software company that specializes in designing and building quantum algorithms and quantum applications. We only build for real quantum computers. So that means working really on quantum hardware. So that's the focus for us, and there is a strong reason for that. We are really keen to push quantum computing into the industry, and we believe that this can only happen if we focus on designing the applications for the real quantum computers. We are focusing on three major areas: optimization, machine learning, and simulations. Hopefully by now you are very much aware about what can be done in all of these three areas. So in optimization, there is a limitless number of use cases. Some of them are tangible, some of them are virtual. So virtual could be portfolio optimization in the banking, and tangible could be logistics optimization in the ports. Machine learning is another area where we have heavily invested in designing algorithms that demonstrate superior performance. And here we talk about use cases such as detecting anomalies. An example could be detecting fraud. And then a third area that looks promising and where we are also investing is the simulations. To be able to deliver the value to customers, our approach regarding the quantum hardware is that we want to be hardware agnostic, which means that we are already supporting all of the major quantum hardware providers. You can see some of the logos here, but this list is not exhaustive. So pretty much any quantum hardware provider that you can think of, we already have integrated into our platforms, into our algorithms. From the commercial success point of view, we have already completed many commercial projects with some of the world's largest customers. You can see some of the names here at the bottom, so from various industries and from various verticals. By now I can say that pretty much every vertical has been covered by us. In other words, we have experience in all major verticals. So just a bit of market perspective, and then I'll talk about how Kipu helps to help with that perspective. Quantum overall has a potential to unlock $1 trillion worth of value for the businesses, spanning from finance to manufacturing to logistics to health and biochemistry, and many more potential use cases. And of course, this means things like resource optimization, energy savings, and many other important factors that will form the future of computing. Kipu is striving to make a significant contribution to this. As an example, when moving classical HPC workloads to quantum, we have been able to demonstrate a reduction of energy by 5,000. I think the big question that everybody is trying to break their head on right now is this intersection point. So when is quantum going to overtake classical? Some companies say it's next year. Some companies say it's later. Keypu says it's now. We're doing the best we can to demonstrate that, and that's why we're doing these commercial implementations together with our customers in the real industry use cases. So we're really focusing on moving quantum into the industry. What's the secret sauce? It's pretty simple. We build algorithms from scratch for quantum computers. So instead of taking classical, so you see the bar at the top, which if you put it on a quantum machine is going to take too much time to execute because it has too many steps in the algorithm. When you port it to quantum, we build algorithms from scratch, from bottom up, with application in mind. The second step we take to further optimize these algorithms is to tailor them for the specific hardware solutions, quantum hardware solutions that are available on the market today. This two-step approach allows us to create algorithms that are minimal in size and therefore can be executed and can bring usefulness and value to the business cases in today's world, on today's quantum computers. Not tomorrow, not in next year, and so on. Today. I talked about use cases and bringing value to the business. Maybe I can share some examples. So the first one you see here is the world's largest chemicals company called BASF, and we are actually one of the major quantum providers for them at the moment. So much of the work that we do for them, including strategy forming for the quantum computing, is being provided by Keypu Quantum. So far, we've delivered not one, not two, but multiple use cases for them, and the strategy working with this customer is that we work with the various business units to offer them potential use cases where benefits can be demonstrated. First case that we tackled with them is the robotics optimization. So we applied our cutting-edge optimizer to work on the robotics use case. So this already demonstrated a success probability improvement of 600x. Another use case that we implemented together with them that you see at the bottom is the warehouse planning space. So just-in-time production and how to reduce the warehouse space that is needed in order to store the various parts. Another use case in optimization, so a car maker with two letters in the name. We have successfully completed two projects with them. One is related to the vehicle routing, so dynamic rerouting of vehicles in real time. And the second use case is capacity planning for fleet logistics. This one is actually quite interesting, the first use case, because it's the first time I personally have seen a real use case where quantum computer is used in real time. So we built together with a customer, based on our algorithms, a solution where the route planning is happening in real time, and you see on the use case demonstrator how the routes are being replanned every 30 seconds. Now, of course, to be able to do something like this, you need to invest quite a bit into hardware. So in this case, we implemented this on IBM, and some of you know that IBM provides a premium plan which allows this kind of thing. So industry is already making an effort to making quantum accessible in real time. However, we already see cases, and this is an example of them, where a solution is updating and doing the re-optimization in real time, and this is quite impressive. To have something like that done on real time, in my humble opinion, is quite impressive. Another optimization use case, and this one is very much related to what you would see in ports. So there is a number of aircraft in this quite well-known company, and they're looking at a potential use case where they can optimize dynamically the flights based on the various factors, such as the availability of the pilots. For example, if the pilot goes on sick leave, which is, let's say, short to medium-term planning, depending on when you know about this. Another factor here is the dynamic fuel price changing. So this is also relevant for the maritime industry. And there is other factors that we are taking into account there when we worked on that use case. Now I will switch to an example in machine learning. We have developed algorithms that can enhance the classical machine learning algorithms. An example here is an analysis of thermal images from drones, where we applied quantum algorithms to increase the accuracy of leak detection in oil pipes. So the result that I can share with you is that we managed to increase the accuracy by 13%. This one, by default, is quantum advantage. Why? Because we are not replacing the classical machine learning. We are doing pre-processing before moving to classical machine learning. So we've enhanced the data. This enhanced data moves to classical machine learning, and you get an incremental or improved result on top of what you would get normally from a classical machine learning algorithm. And maybe to finalize on the use cases, this one here is from a very well-known car components manufacturer, so Schaeffler. And while I'm speaking about this, you can read the QR code because there is a very nice testimonial from customer from 2 days ago. So there is a video of customer telling their story, so how they embarked on this story of quantum and how we helped them on this journey. And I'll talk about how we help customers on their journey in a second. In this particular use case, we helped the customer on simulating the thermal management for the control units for the electrical cars. Due to the large amount of various innovative technologies that we have developed, we strive to make them broadly available to our customers, and that's why we created a platform, which is called Kipu Quantum Hub. This platform makes it easy for you to get access to hardware. It makes it very easy for you to get access to the algorithms, and it also gives you the ability to host the applications, the business applications there as well. With such an approach, you basically can provide everything that is needed to a business unit. So if a specific business unit needs to run quantum, everything is already there, and you can start within 1 day deploying and trying out quantum. We actually built a demo for this event. You can see the use case demonstrator on the right. That's part of the platform that I described. And here the use cases that you got a number of ships, in this case 16, with various routes. And these routes are actually intersecting, so you cannot bring them all at once into the port. That's the challenge that we're addressing here, how to bring the ships into the port and take the minimal time required to bring the ships into the port. So what the use case is demonstrating is by applying the quantum optimization, the optimizer has suggested to bring the ships in 3 lots. First lot being from 8 o'clock to 10 o'clock, then another one from 10 to 12 and onwards. And the algorithm is suggesting that this bunch of ships in the first slot, they are actually not intersecting, and based on the optimization that it's done, it's suggesting to bring these ships at once into the port. Although it's a very simple example of applying quantum to a logistics or to port and maritime optimization, it makes it very easy to understand for people in business who don't have the full context on quantum, on how quantum can help them in their business journey. Yeah, and maybe to talk a bit about the maritime applicability. So many of the things I talked about today in terms of the use cases, they can be applied in maritime and ports as well, because essentially it boils down to the same algorithms and the same mathematical formulations. There is limitless number of use cases also for the ports and for the maritime, and some of them are, of course, vessel routing and emissions reduction, which are, let's say, directly related, optimizing packaging and optimizing the space in the warehouses, in the ports. In the machine learning space, this is detecting all kinds of anomalies. One example could be fraud detection, but another example of detecting anomalies could be actually parts fatigue detection. So we are working with some of the customers on helping them predict when the expensive parts are going to be going out of order. So, of course, if a part costs $100,000, it's very important to predict when it will break so that you replace it before it goes out of service. And of course, if it's on a ship, you have a situation where actually if the part breaks down during the voyage from here to, let's say, South Africa, you're in a situation where you need to bring this on a helicopter. This is a typical, as I understand, it's a typical scenario actually, and this is very, very costly. So being able to predict a broken part before you leave the port is very important, more important than for perhaps some of the other customers where we are already working on this algorithm. And then, of course, in simulations, this can be quite a useful area to look into, especially for shipbuilding, but also can be applied to the marine applications as well. In shipbuilding, I can talk about corrosion research and also thermal simulations and, let's say, fluid dynamics. Just to close off, you see a bunch of people on the screen, so that's part of the company. By the time we take the picture, the picture is already out of date. That's how fast we are growing. And just maybe to focus on the key thing. The value that we bring to our customers is in this holistic approach. So we are able to offer an end-to-end experience to our clients, which means we start by talking to the business people. We understand their key problems, their key priorities, and the key business cases. Then we bring our experts and make a recommendation on where the customer can see early advantage. So we will recommend only to pursue the areas where you can see advantage in the foreseeable future, if not now, hopefully now. We then work together with the customer to formulate this, to prepare to move to quantum. Then, of course, we implement the solution using the cutting-edge algorithms that we have already developed. Then we do the benchmarking, we do the testing, and we compare against classical, we compare against the various hardware machines that are available in the quantum, and eventually we prepare this as a report back to the customer to demonstrate and to explain what kind of business value have we been able to achieve with the customer. So that is how we are helping customers to get on that journey of seeing early advantage and early impact for their businesses. With that, I will finish for today. Many thanks for giving me the opportunity to talk to the organizers, and thank you very much.
Thank you, Eugene.
Any questions? Hopefully there is time for questions.
We have a couple minutes, actually. Are there questions for Eugene about the KIPU work? No? Yes? No? People nodding, shaking? Okay. Well, thank you very much for sharing KIPU's amazing portfolio.
Thank you very much.
Done? So